Okay, so good evening, everyone. We are continuing with solutions to transcendental equations. So, and the last method is the secant method. Now, I said earlier that the easier the method, or the easier the method, the longer the iteration. So, many of those methods they had to like modify them so that the iterations can be faster. So now for secant method is very similar to regular forcing. It's just that the difference is that when you are doing successive iterations, what you are changing is different in regular forcing and what you are changing in secant method. So like this is regular forcing. I'm recalling regular forcing, and you know that if you want to start iterating, you must pick two intervals where the f of the first interval is negative and the f of the second interval is positive. So now in regular falsy, if this is your negative interval, this, and this is your positive intervals. Now when you iterate, and let's say you are getting something like x equals c, then you would have to check. You check that, okay, you check that f of c. F of c would either give you positive or negative. For regular falsy, if it's negative, you are going to have to replace the negative interval here, which means you will not be having a again, you'll be having c, f of c. But it's not like that for secant method. Secant method is just successive iteration, like successive. If here is let's say x2. Okay, don't worry, let me take my time, don't let me rush. But in this case, just remember, you're going to be changing the, as is based on the sign. It's sign biased. But secant method is not sign biased. So what is secant method? Now, I don't like recalling the end formula, so I'll just use one. I've been using one example, so I'll use that same example to solve it, and we'll get the answer. So now the example is the first example, which is x cubed minus x minus 1 equals to 0. So we have solve x cubed minus x minus 1 equals to 0 using secant method. Now, while we're solving this thing using bisection method, we're trying to look for two intervals. And you might ask, or you might have a question, how do I know my two intervals? It's not hard. You use try and error. For this function now, you look at it, okay, let me put 1 into the equation. When you put 1, you have 1 cubed minus 1 minus 1 equals to, so I'm going to be having negative, which means my f of 1 is negative. Now, when you check, okay, f of 1 is negative. Oh, I didn't check f of 0. But if you look closely, you know that f of 0 is also negative. So if I check my f of 2, I'll be having 2 cubed minus 2 minus 1. And this, I don't, in bisection method, I'm not particular about the answer. So here is positive. Now, these are my two intervals. But if you want to make your iteration faster, you can try to shorten your intervals, like make it closer, because the closer it is, the faster and the smaller your number of iterations. So like if you are doing 1 to 2 now, and me, I'm doing 1 to 1.5, the distance between this and this is not the same as the distance between this and this. So you might be doing like, say, 7 iterations, and me, I might be doing like 4 iterations, and I'm done. So let me check for 1.5. I might be lucky if it's positive. Well, now, so f of 1.5. Okay, so I'll be having 1.5 cubed minus 1.5 minus 1. Okay, so what's 1.5 cubed minus 1.5 minus 1? So it is positive. Good. Now it is positive. So I can use these two guys as my interval. So I believe the question of interval is settled. So now, using these two guys as my interval, okay, let me rub this off. Now, in some questions, they will give you your interval. They will specify your interval is. When they give you your interval, please don't pick another interval for yourself. You are not the examiner. So now, since these two guys are my intervals, 1 and 1.5. So for secant method, I will set one of them and I'll set the other one. I'll set this one to be x0. I'll set this one to be x1. So now, secant method is my x2 will become, so I would have x0 f of x1 minus x1 f of x0 over f of x0 minus, okay, f of x1 minus f of x0. Now, this is giving me the regular falsy vibes, but it's just that when you are doing for x3, instead of it to change, like I said in the previous, like I said earlier, instead of it to change the negative or positive, no. So your x3 will be, okay, x1 f of x2 minus x2 f of x1 over f of x2 minus f of x1, which means you don't really need to even cram. Like once you know, okay, this is x3, that means if I'm going for x4, okay, I know my x4 will be x2 f of x3 minus x3 f of x2 over f of x2 minus f of x1. So you just keep doing it and keep doing it until you get till your answer converges. So now let me move on. So let's do something. So okay, so now since these are my two intervals, x0 and x1, then I need to find f of x0. F of x0, and please, while you are using second method, you have to be very, very careful. A simple mistake, and yeah, I think I should try that. Should make a mistake intentionally here, so that you know how to know when you are wrong. Like, because it does not make sense iterating 6 times, and you see that your mistake is in the first iteration. Like, so heartbreaking. So let's move on. F of x0 is 1 cube minus 1 minus 1, which is now we're not saying whether it's negative or positive. We want the value. So this is minus 1. Okay, so then f of x1 equals, what's f of x1? 1.5 minus 1.5. Okay, 1.5 cubed minus 1.5 minus 1, which is 0.875. So now using second method, you have x2 equals, okay, so we have x0. X0 is 1 in brackets f of x1, 0.875 minus, this is x0. So you have x1, 1.5 in brackets f of x0 minus 1 over 0.875 minus 1. So punching that, you would have good. You would have 1.26667. Now, here's the trick. If your answer is to be in 3 decimal place, when you are iterating, don't let your answers here be in 3 decimal place. It will not converge easily. So let it to be in like 4 decimal place, 5 decimal place, so that by the time you are doing your iteration, before you do 2, 3 to convert, because the more you are approximating your answers, the further the accuracy. I don't know if you understand. So let's move on. X3. So x3 will be x2. So let's, okay, good. I've not done something here. I'm missing something. So if x2 is 1.2667, okay, 667, I will need f of x2. So f of x2 will be, so f of x2 is giving me 0.23437. Okay, so x3 is x1. So where is x1? 1.5 in brackets f of x2. Okay, minus 0.23437 minus, so this will be x2. X2 is 1.26667 in brackets f of x1. F of x1 is what? 0.875. So you can see this one is here. So when you are doing your next iteration, it's going to be here. Over minus 0.23437 minus 0.875. So using your calculator, you'll be having 1.5 Good. So I'm having 1.3159. Okay, let me add one more decimal place. Let's say our answer is to be in let's say 3 decimal place. So let me add one more. Let's say 6. Now, what do you notice? You notice that okay, yeah, from 1.2 I'm going to 1.3. Okay, so this is just this is the second iteration. So I'm not expecting to make a mistake in the second iteration. But take for example now, if you are doing probably your fourth iteration and you are seeing that this answer is going towards a point, but let's say you're having 1.2, you're having 1.3, your next answer is 1. Let's say 32, and you are doing your fourth iteration and you're having something like, let's say 1.2 again, like something is going like this, is going like this, then you're doing an iteration and it goes back, then it's either probably it might be like that, or probably you've made a mistake somewhere. I don't know if you get my point. So you can look at the answer and say, oh, this thing is supposed to converge to a certain number, and okay, somewhere I might have made a mistake in my iteration. So let's watch out for that. So okay, moving on. I think I can do x4 here. So x4 becomes x3. Oh, I'm missing something. So x3 equals 1.31596. So I have f of x3 equals, so I'm having minus 0.0.03703. So I can go for x4. So x4 is, that will be x2. Yes, x2. So where is x2? So x2 is 1.2666663. Okay, 7 into bracket f of x3 minus 0.03703 minus x3. x3 is 1.31596. f of x2. f of x2 is minus 0.23437 over this minus this. So you have minus 0.03703 minus 0.23437. So you have 1.2 it should not really mean actually. Let's move on. 1.2667 minus 0.03703 minus 0.23437. Okay, so I'm having 1.3252. Okay, so I think I'm on track. So x4 is giving me 1.3252. Okay, I think I can take this off. Then the next thing is I need to find f of x4. So x4 equals to 1.3252. f of x4 is 0.002095. So x5. So x5 will be x3. So where is x3? x3 is this. So I have 1.31596. f of x4 0.002095 minus x3. So this will be x4. x4 is 1.3252 in brackets f of x3. F of x3 is minus 0.03703 over, so 0.002095 minus, another mistake I'm susceptible to is I can just do minus and forget this minus here. Please don't forget it. So solving again, you have 1.31596 okay. Okay. So I'm having x5 equals 1.3247. Okay, so to two decimal place, I can see that I'm having a consistent answer, 1.32, 1.32. Okay, so this is 3252, okay, 3247. Well, we're not far. So let's do one more. Let's do x6. So x6 is going to be x4. Okay, always forgetting. x5 equals 1.3247 and f of x5, wow, minus 0.00, wow, 5 times 5 4, say 543. Okay, so x6, so x6 is going to be, I think I would stop at x6 because I believe it should converge there. Okay, so x6 is x4 1.3252 x5, okay, f of x5 minus 0.0000543 minus x5 1.3247 f of x4 0.002095 over minus 0.000543 minus 0.002095. So punching the calculator, 1.3252. Okay, so it gave me 1.3247 to 4 decimal place. Okay, so, and I assumed our answer is going to be in 3 decimal place. So since x5 equals x6, so we can say an approximate answer for that solution. Therefore, the approximate, because really in solutions to transcendental equations, you can't really get the exact answer. We get approximate answers. So the approximate, let me define the answer, 1.3247. And I think this was the answer I got in the previous video also. So for this same question. So that's all for second method.